Okay, let's continue. Last week we were speaking about ER diagram. Almost we reach this diagram. I will make fast revision only for ER diagram. Last time we had this example. Please turn off your mic. You can only turn on your mic if you have a question. Otherwise, please keep your mic off, okay? We have this example about the company database. This is a description for requirements. Saad, could you please turn off your mic? Okay, this description for company database should come from software engineer after collecting the requirement for the system. Then, as database designer, you have this description. Then you need to design and build your database starting from ER diagram. As we saw last lecture, we tried to get entity type, like we have here 4 entity type come from the description: department, employee, project, and dependent. Adil. Okay.
Sorry, doctor.
I don't know. We are playing or what? It's last time I accept something like this, okay? Okay. This example we extracted for entity type. I think this most of you big adult enough to understand the situation here. I don't want you to open your mic again. Even if you have a question, write it. Don't open your mic, okay? For this company database, we extracted from this description 4 entity. How to get the entity type from the description? We already mentioned that, but I will mention it again quickly. When you have some part from your system that you want to keep data in your database about it. For example, here the company is organized into departments. This do not have anything, okay? Each department has a unique name. Then we start to speak about data that should be kept about this department. So we get department here as entity because we need to keep some data about this department. Then the part from the system, the entity, the thing from the system that you want to keep data in your database or track its data, considered as entity type. Okay, then we continue to read. We keep a track of start date, department, control number of projects, each of which has a unique. Here's a description speak about the project, that we need to have a unique name and unique number and location for the project. Then we also extracted projects as entity. The database will store each employee's name, blah, blah, blah. Then we need to keep information or data about employees. Then we have employee, and if you continue reading, you will see that we need to keep information about dependents for each employee. Then we have dependent here. Then we extracted the relationship. You will find that there is something to link between two or more entities during the description. Then you can find the relationship. Okay, let me just change the color here. We already mentioned all this last time. Okay, the company and each we keep a track of starting. Okay, here we keep a track of the start date when that employee began managing the department. Then here there is a relation between employee, which is an entity type, and department, another entity type. Then we have this relationship that there is one of the employee managing the department. Then we have this relationship. Okay. If you continue, you will extract all the relationship same way. Then we start to extract. Attributes, or in another term, it's data that we want to keep about these entities or relationship. So you start to get the data. Department has unique name, unique number. Okay. Department have unique. When you hear the name unique, this means it's a key. We define the key that it's a unique attribute that can identify the entity. So we have number and name as keys, attribute and key at the same time for this department. That's why we put under a line under the name of the attribute. And a particular employee who manages the department. Okay, here it's about relationship between employee and department. We keep a track of the start date. Okay, start date attribute, but this attribute belongs to which entity type? Here, we keep a track of the start date when. It's important here, word. when that employee began managing the department. Then this starting date do not belong to employee or department. It's belong to the relationship between two entities. When this employee began managing this department, that's why we put this attribute for the relationship. So some attribute belong to the relationship, not for the entity. Then you continue reading here. A department may have several locations. Then a department, this means this information for department, it's have several location. This location attribute, but several location means we have here multi-valued attributes. That's why we used double line oval. Normal oval for normal attributes like this, and double line for multi-valued attributes. If you continue like this, you will extract all the information here or the attributes here. I will mention only some types or some attributes here. We have number of employees. Number of employees, it's a derived attribute that calculated from how much employees works for this department. Okay, another type of attribute, name. You will find that name, it's a composite attribute that have 3 parts. Composite attribute also can run like this. Another thing that I want to focus here, I will give another color. Okay, here the database will keep track of the dependent of each employee for insurance purpose. May have a number of dependent, including each dependent first name, sex, birth date, and okay, relationship to employee. Here, have relationship, birthday, sex name. Which one of these attributes for dependent considered as a unique value? Here we don't have unique value. We don't have, in another term, we don't have key for this entity, dependent. Because relationship, okay, maybe a relationship, for example, son or daughter, another employee have son or daughter. Birth date, maybe 2 dependent for 2 employees have the same birth date. Same for sex. For name, maybe one employee have son named Ahmad and another employee have son also named Ahmad. So because this entity type do not have any key, we consider it as weak entity. We define weak entity. It's an entity that do not have key. If your entity or if an entity do not have key, then it's weak entity. Weak entity, we use a double-lined rectangle, not normal rectangle. Here, entity type. Here, this one, weak entity. Also, we mentioned recursive relationship here between one type of employees and another type, supervision. Some of the employee will be supervisor for another employees. So here in recursive relationship, you need to define the type of the entity here for each side of the relationship. Maybe okay, you can ask using sound. Okay, you can, anyone want to ask a question can ask, can open the mic, but please don't open the mic except if you have a question. Okay, I will answer this question. It's depend on the description, but maybe use another term that have each employee have a unique name or have different name from others employee. Any terms that deliver to you the uniqueness value for this attribute. So if you understand that this attribute unique, even directly it's unique, or it's not redundant, or no other employee or no other project have the same name. It's depend on the description, but you need to understand that it have unique value. If you understand from the description that it have unique value, then it's a key.
Okay, sir, thank you.
Okay.
Sorry, doctor, I have a question.
Okay, come in.
I don't understand number of employee. Why you draw in this line?
Okay.
And from where you get this?
Okay.
Okay, doctor.
Let me check if this in this description or in the book description. The company is organized into departments. Each department a particular employee who manages. We keep a track of the star. Okay. Okay, let's read here. It is required to keep a track of the current number of hours per week that an employee works for each project, as well as. Okay, it's not in this description. Let me open the book directly. I think it's the description here. Think it's the same description. Okay. Actually, just to give you an example for some types of entities that not come directly from the description, but you need it. For example, sometimes you need the age of the employee. if you need the age of the employee, then this age we usually don't keep the age. Why? Because it's a changing value. So the values that change, usually you calculated it. This type of calculated values for attribute cannot be kept in the database. It's as it. We usually calculate it or derived it from another information. If your birth date, for example, 1st of January, for example, let's say 1990. Then your age now will be different than after 1 month, after 3 months, after 4 months. Okay, each time you will open the data, it will be changed. This type of data usually need to be calculated and derived from other data. So if you need to keep the age here, then it will be calculated from birth date. Here, it's not actually in the description that we want to keep a track for number of employees. But the book gives this example because we need to give example for each type of attribute. So this derived attribute come from the relation between department and employees. So you calculate from this relation how many employees belong to this department. This number, changeable number of employees. Maybe you have new employees or you have retired employees, something like this. So because it's changeable, it's derived. Okay, actually it's not here in the description, but if I want to put it in the description, I will say we want to keep track for the number of employees for each department. Okay, you will not differentiate it from other type of attribute here if you did not understand this data come from where. So you need to understand that number of employees usually calculated because you don't have specific number for each department. That's the issue. Also, it's depend on your understanding. And if you see, when I will give, for example, homework today, I mentioned that you can make any assumption here. You can give your idea in some parts you need to make some assumption. Okay. About the software that we use here to build ER diagram, you have too many softwares. Even you can use Microsoft Word. For me, I use this software, eDraw Max, and I send it to you. Let's continue now. Until now, we just make like a revision. If you watch the video for last lecture, you will find the description as a discussion for this part until I think here. We speak about recursive weak entity and attributes. No. Which slide we reached last time? Okay, I think this one. Okay, as we so we have 4 entity types: department, project, employee, and we find the relationship between each of these entity types. Of course, 2 entities could have more than relationship, as we mentioned before. For example, this department employee have 2 relationship. Works for that we have some employees works for that specific department, and manage that we have 1 employee that manage each department, have different employee manage it. Okay. Now, between 2 entities, we could have, as I mentioned, more than 1 relationship. Now, new subject for ER diagram, that the constraint or relationship. We have 2 types of constraint, or we named it usually ratio constraint. Actually, we have 2 types of ratio constraints here. The maximum value of participation from each side. You have, for example, entity for department and entity for employee, and they have relation works for. So we need to know how many entity from entity type department and entity type employee will participate in this relation. We have maximum number of participation and minimum participation. For maximum participation, we called it cardinality ratio. Cardinality ratio. And for cardinality ratio, we have 1-to-1 participation. This means 1 instance from entity type X with have relationship with 1 instance from entity type Y, for example. Like we don't have here a drawing for this one, but let's see here. Like this relationship manage. We have 1 employee that manage 1 department. Then maximum number of departments that the employee can manage 1, and maximum number of employee that can manage department 1. This means 1 department have 1 manager. 1 employee can manage maximum 1 department. This the maximum participation. We called it cardinality ratio. We will see how to find this cardinality ratio. We have 3 types of cardinality ratio. 1-to-1, this means each part instant maximum share from each part. 1-to-many, this means the 1 entity have maximum 1 participation in this relation. The other part can have more than 1. Many-to-many, then each part can participate in this relation more than 1 instance. Okay, let me now go to our diagram or example, and we can check each one of this. Okay, now also from the description you can find sometimes you need to understand the environment you have here you analyze it, you need to understand it to know how much the maximum. For employee works for department. Let's read here. Works for, okay. A company unique number. We keep a track of start date, employee begin. A department controls number of a project. Okay, an employee is assigned to one department but may work on several projects which are not necessary. As in, it is required to keep a track of current number working hour. Okay, here, no information. That's why I mentioned that. Sometimes you have the relationship, but you don't have information about cardinality ratio, but it's very clear. Let's make it here for us. Employee, when you want to calculate the cardinality ratio, you do like this. One employee works for how many departments? It should be one department. Okay. Then one employee can work for one department. Now we take the other side. One department can have many employees working for it. So you take both sides, then you take the maximum. 1 and 1, the maximum 1. And 1, the maximum n. So we have here one-to-many relationship. One-to-many. Another time. Department and project. Let's find the relationship between department and the project. A department control a number of projects. Here mentioned that department control number of a project. Okay, is there another information about this relation? No. Then we have that one department can control many projects. Of course, one project, the other side now, one project can be controlled from only one department. Then here, 1 and 1, we take the maximum, which is 1, and 1, we take the maximum, which is n. Then we find here the cardinality ratio from department to project, that it's one-to-many. And so on. This about cardinality ratio. Any question for the cardinality ratio?
It's okay, Doctor.
You want from me to continue all the relation?
Yes, Doctor. Yes.
It's okay. I continue, but more quickly. Okay, employee works on a project. Here, it's mentioned that a department control a database will so employee. An employee is assigned to one department but may works on several projects. Okay, then, and of course, here, one employee can work for several projects. We take the side from employee to project. Now the other side from project to employee. One project could have many employees working for it. And here, this number different than this number. That's why we use here M and we use here N. So the maximum will be N this side and M for this side. Okay. Then the relationship between employee and the project, many to many. Okay. For employee and department, you will find that one employee can manage one department, and one department will be managed from maximum one employee, then 1 to 1, 1 to 1. This means the maximum from each side will be 1. That's the relationship between department and employee. The managed relationship will be 1 to 1. Same thing for supervisor and supervise. Okay. One supervisor can be supervisor for many employees, and one employee can be supervised by only one supervisor. So the relationship here, we take the maximum because cardinality ratio, the maximum for each side. Okay, now employee and dependent. Okay, one employee could have many dependent, and one dependent should be for one employee. Then the relationship here, 1 to many. We take the maximum here, which is 1, and the maximum here, which is N or many. Okay, is it clear how to get the cardinality ratio? Okay, we continue. If you have any problem with cardinality ratio or any question, you just ask me. Then this is the cardinality ratio, and it's very important. It's very important. I will mention this many times. Cardinality ratio, very, very important, because later when we convert or mapping this ER diagram to relational model or to database later, this will make big difference. Okay, to connect between the tables and to build your database, this will make a big difference. If the relationship cardinality ratio wrong, then all your database will be wrong and will have a problem. So you need to focus here in cardinality ratio. Existent dependency constraint. From its name, we called it shortly sometimes participation constraint. How many instance or entity from each part from the relation, how minimum participation, the minimum participation. It could be 0, the minimum participation, or it could be 1 or more. It doesn't matter if it's 1 or more the minimum, but it will make different if it's 0, not exist dependent, or 1 or more, we called it exist dependence. Same thing here, but we will ask the question for each way. It's like this. Is there a dependent? Is there a dependent without employee? No, you cannot. You don't need to register independent information if no employee that own or owner for this dependent. Then this full participation cannot be zero. But the other side now, employee, do you have some employees that don't have dependent? Yes, there is some employees single, don't have wife, don't have kids. So here, not zero participation for existent dependency or minimum participation. Here we were in cardinality ratio, we're looking for the maximum participation. Here we're looking for the minimum. So we will ask a simple question. This entity, is there any type of this entity that will not share in this relationship? If yes, then it's not existent dependency. If no, this means the minimum will be zero, the minimum. Minimum zero, we use single line. If one or more, we use double line. It's better to use this one, okay? Let me use this software, it's better here. For eDraw Max, if you want to use this one, ER diagram, Shen ER diagram, okay? Because it have all what we need for ER diagram. Just we focus here, this one, dependent cannot be zero for this relationship. Why? Because each dependent should have employee. So we make this double line. We will remove this single line and make it double line. Okay. For employee, is there any employee without dependent? Yes. So the minimum will be zero. That's why we use single line. Okay, come for this one. Works for department. Is there employees that not working for department? No, employee should work for department. Then this one should be double line.
Doctor, please, can I ask you?
Yes, sure.
Doctor, should the weak entity have full participation on a strong entity, or that is not necessary? It depends on our diagram.
Usually weak entity will have full participation like this, because weak entity cannot exist dependence alone. The existence of weak entity usually depend on the owner entity. We call this entity owner entity. So usually will be full participation in the relation here. This could be zero participation. Okay, some employee maybe don't have a dependent or weak entity dependent, but the other side, weak entity cannot be zero participation in this relation. Should be full participation. Okay, clear?
Thank
Yes,
you,
clear,
Doctor.
Doctor.
Okay, we now look, we already finished to speak about cardinality ratio. We now speak about existent dependency. Is this relation full participation or could be zero, the minimum? Okay, so we take each side. For department now, do we have departments that don't have employees working for it? It should be not, yes, but it's depend on the requirement. Also, any dependency depend on the requirement. Oh, okay. Department and project. Some department maybe don't control any project, but all the project should be controlled from department. So department controls, maybe you have some department not control any project. That's why here not full participation, but here full participation that control it. That's why here have full participation in this relation. Full participation, we use double line. Same thing you can for department and manager. Each department should have manager, yes. So this one, at least one manager, and that's maximum one manager. One and one only. So this full participation. But not all employee manage department. We can take employee X, not a manager. So you have minimum zero here. So it's not full participation. Works on some employee not working for project, but all project should have employees, or it's depend on the description. Maybe at least have one, if they mention that it at least have one employee. I don't know. Let me return to the description. Where is it? Oh, why I come here? From here, let us see here directly. From here, this means that each employee should work for at least one project. Then you can see it's full participation. Sorry, I have phone call. Just a moment. Hello. Okay, okay. I don't know what happened exactly, but maybe because one of you starting the meeting before me, I don't know if he has the priority to exit or not. Anyway, I don't know what the last thing that you get from me, so I will repeat the issue about weak entity again. Next time, please, no one should start the meeting before me. Okay, about the weak entity. Weak entity is an entity that do not have a key attribute. As we mentioned, key attribute, it's a unique attribute that can identify the entity type. So if you don't have, sorry, I did not share the screen again, I think. How many students around? I feel that there's some problem here.
I'm here, doctor.
Yeah, here, Doctor.
Okay, okay. I don't know what happened exactly, actually, but let's continue. I think last thing that we lose the connection here was the weak entity. Okay. So weak entity do not have key to identify it. That's why it need an owner or identifier entity to identify this relation entity or weak entity. To identify weak entity, is there a problem here?
Doctor, if you want to, we will can do out and come back again.
No, I think only one student had a problem here.
Maybe someone make it the 25.
Yeah, okay, I think no problem now.
Yeah,
Because
we
we
can hear you
don't
now.
have too much time, that's why I don't want to. Just turn off the mic, please. So to identify weak entity, you need two things: a partial key and the owner entity, or in shortly, the owner entity key. Okay. So like this, you can identify the weak entity. Okay, owner entity, we know it, and we know the owner entity key. This means, in this example, we have weak entity dependent and owner entity employee. We called it identifying entity or owner entity. So, as I mentioned, because we don't have any attribute that identify or uniquely identify this dependent, it's a weak entity, and it needs the owner entity to identify it. That's why we call this identifier entity or owner entity. Okay. How to identify this weak entity? You need to choose one of the attributes of this weak entity as a partial key. Which attribute we can use attributes that unique when you connect this entity with the owner entity. For example, if we have employee X and it's have 4 dependents. Let's check this relationship. Okay, you can find two dependent as son. Then you cannot find or you cannot take relationship as partial key. Birth date, maybe he have 2 sons or 2 kids with the same birth date. Also cannot uniquely identify. Also gender cannot uniquely identify because maybe he have 2 boys, 2 girls, 3 girls, like this. But name, you will not find dependent for this employee that have the same name. But you can find the same name with another employee. So to identify this weak entity, we need partial key. We will take partial key here, name as partial key. We will take name as partial key. We use
Please, doctor, I have a question.
let me continue, then ask your question.
Okay.
Okay, so we identify the partial key by the dot line like this under it, and the owner entity. So if we connect between this owner, we have its key, for example, social security number. So employees that have number X with his dependent, so we can identify a specific dependent if we connect this partial key with the owner entity. Yes, go ahead, please.
Yes, doctor. Can we take 2 attributes and consider them as unique or partial key? Like name and sex, or name and birth date.
Of course you can take, but if one can be unique, you don't need to take more than 1 attribute. But sometimes the key could be from 2 bars or more. When we take the relational model, you will find some tables, some relations that have more than 1 attribute as a key. So you can take more than 1 attribute as a key in some cases, okay? And actually to make it easier for database, they usually use artificial key. Artificial key means keys that come from the system itself, like for students. Each students have, for example, a Chemlec number could be, it's unique, yes, but you will find that they use student number. This type of numbers, we call it artificial key because we find it in the system, like sequence number or ID number that come from the system itself. So we use this way to prevent any problem in our database. Sometimes we bring a key from the, we suggest a key as a database designer, okay?
Okay, Doctor, thank you.
Do you have classes after this? Any of you?
For me, no, Doctor.
Yes, sir.
Okay, because I think we have only 20 minutes, but we have to finish. We have to finish. Okay, we'll continue here. We reach weak entity. Okay. We already mentioned this. Okay. Oh, seems after I mentioned this, I return to the weak entity again, because we already mentioned cardinality ratio and participation constraints. Okay, another notation or another way to define cardinality ratio and participation constraint using the min-max notation. Turn off your sound. If you don't have a question, just turn off your mic. Saad. Saad Habib, many times your mic turned on during our lecture.
None.
Just
Okay, Doctor.
focus on your mic, okay? If
Okay,
you have a
Doctor.
question, just turn it on.
No, Doctor. No question, Doctor.
Then turn off your mic. Okay. I will not focus too much in this notation. It's another way to describe or to define this cardinality ratio and participation constraint, but using another way of notation. We will take the examples just to understand it. Okay. Here it's different than the way of calculating the or identify the cardinality ratio. Here you will take each side and find what's the minimum and the maximum for each side. Okay, you have this manages relationship between department and employee. Here you take minimum max for each side separately. Last time we was speaking about one to many, many to many. Now, no, we take minimum maximum for each side separately. Here, employee. Some employees will not manage any department, then the minimum will be 0. Employee maximum manage one department, then the maximum will be 1. So the minimum will be 0, that the employee will not manage any department, and the maximum that will be 1, some of employees will manage only maximum 1 department. So this is the minimum and this is the maximum for each side. Okay, from this side, department. One department, sorry, here, the minimum. Each department should manage by at least one employee. This means the minimum will be one, and at maximum will be managed from one employee also. Then the minimum will be one, the maximum will be one. Okay, department and relationship works for employee. Employee should works on at least, this means the minimum, at least one department, and maximum also in one department. This means should work for one and only one department. From the other side, the department should have at least one worker, and you have many workers. We don't know the exact number. Sometimes you have the exact number for the maximum and the minimum, as we can see later in this diagram. Let's check here. Here, what's the meaning here? Here's the meaning. The minimum number of employees that should work for the department should be 4. And there is no maximum number. Maximum number n. This means more than 4. Okay, here, controlling department and project. We have some departments that will not control any projects. This means the minimum number of projects that controlled by the department will be 0. The maximum number will be n. It could manage as many projects as can. Also here for project and employee. Okay, you can find here that the project should have at least one employee working for it, and maximum n. Employee should work for at least one project and can work for many projects. For supervisor and supervise. Okay, supervisor could manage or could be supervisor for non-employees. I don't know, it's depend on the requirement of from the company. Or okay, we need to have supervisor without any employee under it supervision, and maximum in. Maybe he have many employees under his supervision, and some employees don't have any supervisor. Maybe chief information, CIO, or maximum one supervisor for this employee. All this minimum, maximum should come from the requirement of the system. If you have one question or in exam or anyway that don't give you information about this, you need to try to understand what's the system exactly and make some assumption here. Okay, this for ER diagram. We use ER diagram for relational database. Modern systems usually use object-oriented view for the system and use another type of alternative notation, which is UML, Unified Modeling Language, UML. For Unified Modeling Language, you have many type of diagrams. like activity diagram for the project activity, and like a class diagram, which is alternative notation for ER diagram, but usually used with object-oriented projects. Okay, so UML, especially class diagram, another way to display ER concepts. About the class diagram, we will take one example and see the notation. It's same way about thinking for ER diagram. Same way. You need to find the entities, which is classes. We called it the classes here. In UML class diagram, we call the entity type classes. But to find the classes, it's similar idea with finding the entity type. Okay. Then if you have the same description, you can find the entity or you can find the classes. Classes will be presented as a rounded box, and it have 3 parts. Okay, first part, the name of the class. It's similar as the name of the entity. For example, you have employee class or something like this. And the second part will be the attributes. Will contain the attributes like employee SSN, social security number, or ID in some countries. Or here in Turkey, we called it kimlik number, okay? Name, blah, 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 all the attributes. The third part will be the class operation or functions and process. For example, add employee, delete employee. Okay, this I think the only different for between employee and entity type was its attribute, that we have the functions or the process, or we called it a class operation section. Okay, 3 sections in each class: name, attributes, and class operations. This example, same example, the company database schema, you will find the same classes or same entity: employee, department, project, and dependent. Okay, here in department we have the attributes, and we have some functions or some process like add employee, number of employee. You look here, number of employee as derived attribute was in the relation. Now you can calculate it here for object-oriented view, okay? Or any type of functions. This functions or process that can be done on the data and on the relationship. And here's the minimum and maximum notation. Same thing. We use only here the star for, instead of an, we use the star. And the name of the relationship will be on the connection between the classes. But if you have some attributes, so you make the relationship like class here, because it have name and have attribute now. So you make it like a class, but you will differentiate between the normal class and it by using this dot connection. Okay, here only the location. It's about generalization. Okay, you have location in this class department, and you have location in this class project. If you return to our draw here in ER diagram, we have location in project and location in department. So make like the generalization for it, make it in one class and connect between it and the other classes. Not in ER diagram, just only in UML class diagram. So the connection will have this notation to mention that this aggregation notation. This means this come part from here and this return as part from here. Even recursive will be like this. Okay, this UML class diagram. I will continue for another maybe 15 minutes. Okay, is it okay for all of you?
Yes, Dr. Hassan.
Sorry, I did not
Okay.
take a break because we already late.
It's okay, don't worry.
This should be for week 2, and we are week 3 now.
Okay, doctor.
Okay. Now, if you look to our previous ER diagram, you will find that the degree for all relationship is binary. This means connected between two entity types. You see here, let me just clear everything. You see the relationship, all binary. Even this one, it's binary because it's between supervisor and supervise. But we have some type of relationship more than 2, maybe 3 or an degree. So we have ternary. It's maybe you can find sometimes ternary, but more than ternary, it's not common because it's very rare, because it's very difficult to define here the relationship and the constraint if you have more than n equal to more than binary. If you have 3, you will find difficulty, but more than 3, you will have more difficulty to define the constraint. Sorry, where I went? I should stay here. Okay, let me show example here. We have this ternary or 3 array. The degree here 3 for this relationship supply. So we have a supplier that supply project parts for specific project, and we have a quantity for the relationship. Why? Because this specific supplier supply this specific parts for this specific project, and this is a quantity when he supplies this part for this project, because every time you will have like same supplier supply another parts for the same project or for another project. So this quantity comes from the relationship between supplier, parts, and the project. That's why we put this entity for this attribute for supply relationship. This example for ternary relationship, This another way to present this relationship, but this way will not give you the correct information. Because here, okay, this is a project connected with this part, and this part connected with this supplier, and this supplier have or supplies for this project, but can supply for other projects, and this make too much confusion here. That's why it's better to make it like this. Or another way, using weak entity. So you can convert this ternary relationship to weak entity. This make it easier to define the cardinality ratio and other constraint. So this ternary relationship could be converted to weak entity, and this weak entity will have relation with each part. You look, it's same, and when you convert this relationship, we will see, maybe not next week, after 2 weeks, we will see how to map this type of relationship. This type of relationship, for example, when we convert it to tables or relation, will have separate. It's not from this chapter, this after 2 chapters. Okay, we will have separate relation or table with the content, quantity, any attribute on the relationship, and the key for all the entities that sharing with this relationship, project name and supplier number and also part number. Then it will convert to table in your database finally. It's same if you make it as weak entity. It will be more clear when we speak about mapping from ER diagram to relational model. Okay, now this is another example. You can look to it at your house, and if you have any problem, you did not understand anything here in this example, you can ask me or return to me. We have homework. Okay. You have around 1 week to do this homework, and please submit your homework using OIS system. Of course, you know this system. You will find in the system here, I already, let me only, okay, I think OIS. Okay, you will find here your homework, and you can, I think it will open after this class, maybe 3 p.m. Then you can submit. Here you can submit your homework. The homework should be done individually. You need to design ER diagram and indicate everything, the keys, cardinalities, ratios, constraint, relationships, entity, attributes. You can make any assumption, but without deleting or removing any part from the homework. You can add, but not remove any specification here. And this description for the ER diagram. Okay. It's a bank database, and you need to draw ER diagram. If you did not attend last lecture, you need to watch the video for the last lecture, okay, to understand the ER diagram more, how to find the entity types and relationship. Okay, all mentioned last time, also this time, but mentioned more clearly last time. That's all for today. Inshallah, see you next week. Hopefully you will done your homework. Okay.
Okay, Doctor.
Thank you, Doctor.
Inshallah.
Actually, this homework will help you to get better marks, inshallah. I will not consider any homework that done between more than one student. You should do this homework yourself alone.
Doctor, please, is there any degree about that homework? Or without?
I will put extra degrees.
Okay, thank you.
Thank you, Doctor.
Okay,
I
for
have
the
a-
homework.
Okay, thank you.
If you did not submit the homework, this means you don't need any extra degrees. Yes, and I think for especially for PhD students, they need high mark to pass the course.
We want your help, us, please, Doctor.
You help yourself. I help you by give you some homework, some presentations, but you need to study and help yourself.
Of course.
If you
Thank you, Doctor.
done the homework, then I helped you and you helped yourself. Okay, that's all for today. Have a nice day and inshallah a nice week. See you inshallah next week. Assalamu alaikum wa rahmatullah.
Assalam.
وعليكم السلام.
Brochures inshallah.
عليكم السلام دكتور ورحمة الله.
السلام ورحمة الله.